Okay, for number 3, we're talking about a right triangle, which I'm going to draw up here for a second. It doesn't matter how you draw it as long as it's a right triangle. And they're saying that the height is changing. The height's increasing at 1 inch per second. Since that's how fast the height is changing, that is the derivative of the height with respect to time is 1. It's increasing, so it's positive 1 inch per second. Okay, let's just drop that in there. The base is increasing at 3 inches per second. Since that's the rate of change of the base, that's dB over dt, and that's positive 3 inches per second. So I know these two rates of change. I know how fast two things are changing, b and h. Okay? At this point, I can ask you to find out how fast a lot of other things are changing. The triangle has a third side. It's got angles. It's got a perimeter. In this case, I'm going to ask you how fast the area is changing, specifically when the height is 4 and the base is 9. Now, these are not rates of change. Those are measurements. So we can use those to find other measurements if we needed to. Like we could do Pythagorean Theorem to find this side up here if we needed it. But we don't need that side up there for this question. So, and that's something that I saw a lot of students did. They did Pythagorean Theorem here. That doesn't make any sense in this particular question because I'm not asking you about that third side. I'm asking about the area. So we need to use something that has the area in it. And the area of a triangle is 1/2 the base times the height. So, if I wanted to know what the actual area was, I could just plug in 4 for the height and 9 for the base, and that would tell me the area at this moment in time. But that's not what we're looking for. We're looking for how fast the area is changing, which means we need dA dt, which means we need to derive this equation so we get an equation that has dA dt in it. So if we derive that equation, I'm going to draw a little bar here to separate this. The left side just becomes dA over dt. But the right side has multiplication in there. And like we discussed with derivatives way back in the day, if you're going to derive something that has multiplication between two different changing values, two different functions, I guess, then you've got to use the product rule. So I'm going to put 1/2 b together. So that's one thing. And I'm multiplying that times h. So the product rule says derive one, leave the other to start off. So I'm going to derive 1/2 b. But the 1/2 doesn't change anything. Deriving b gives me dB dt, and that's times h plus. The reason why I don't have to do the product rule on 1/2 times b, even though it's multiplication, is because one of the things we're multiplying is a half. That's not changing. You don't need to do the product rule at that point. Just like if you had to derive 5 sine of x, you don't do the product rule there. Like if that was y, then y prime would just be 5 cosine x, right? The 5 just kind of hangs out. That's what's happening with that 1/2. So the derivative of 1/2 b is 1/2 the derivative of b, dB dt. And that's times h because the product rule is happening. And then we're going to add that to, we're going to leave 1/2 b alone and then multiply it by the derivative of h, which is dH dt. And this gives me an equation that says dA dt is going to be equal to, we can find it if we know dB dt, h, b, and dH dt. If I know those things, there's 4 variables over there, I can plug them all in, and I can simplify it down, and that'll be what dA dt is. And it turns out I know all those things. So let's write this out. dA dt is going to be equal to, the 1/2 is there, dB dt is positive 3 inches per second, and h at this point is 4 inches. So by the way, we're multiplying 3 inches per second times inches there, because 4 inches. And that's going to give us square inches per second, which should make sense because it's how fast the area is changing, and the area is measured in square inches. So its rate of change should be squared inches divided by some measure of time, in this case seconds, because that's how we're using seconds for all the other rates of change. Okay. Plus, we're going to have a 1/2 here. All right, the base at this point is 9. They told us that right there. And the rate of change of height happens to be 1. And these are all numbers. I just made these numbers up. I just gave you some information so you could plug them in. There's nothing special about these. 1/2, 3 times 4 is 6. Plus 1/2 of 9 is 9 halves. And 6 is 12 halves, really, if you think about it like that, right? Plus 9 halves is positive 21 halves. And again, the units on that, what you got to remember, are inches squared per second, or right second.